In this example, we're going to talk about unequal tangent vertical curves. So we're looking at a sag that has a slope coming downhill at a negative 2% and a slope going uphill at a positive 1.6%. So it says a negative 2% intersects a positive 1.6% grade at station 87 plus 00 and at elevation 743.24. So that's this point right here. So that's where they intersect, going downhill and then back up. The next thing it says is it's a vertical curve with a length of L1 of 400 feet is extended back, that should be back, from the vertex, and a length of curve L2 600 feet running forward, closely fit ground conditions. Compute and tabulate the notes necessary to stake the unequal tangent vertical curve at full stations. So what it means is at full stations is basically 100 feet. So if my station here at that vertex is the 87 plus 00, and it says from the vertex point to the beginning of vertical curve is 400 feet. And from the vertex to the end of vertical curve is L2, and it is 600 feet. So what it's saying is from here, we have two curves that we're going to be looking at. A vertical curve coming from beginning to the PVI and from the PVI to the end. Now when we do that, we're actually making two separate curves. Okay, now we can now treat these curves, for example, now this becomes the PVI of this curve L1, and this point here becomes the PVI, or the vertex, of L2. Okay, now L1 said it was 400 feet. So from here, from the vertex to the end, is going to be 200 feet. And in this one, this said that it was, the L2 was, 600 feet. So from here to here is 300 feet. From the beginning of the second vertical curve to the end is 300 feet. All right. So when we're looking at this information, we're looking at, okay, where are these stations at? If we know from the actual vertex and it says it's 400 feet back, we are saying 87 plus 00 minus 400 is going to give us our beginning of vertical curve of 83 plus 00. Now the end is going to be the vertex at A that we figure out here has to be adding the 200 feet back. So if this is 83 and it's 200 feet here and 200 feet here to make the total 400, then the vertex is going to be 85 plus 00. Whereas on the second curve, we know that the beginning is 87, which is, the CVC stands for compound vertical curve. So we got to figure out what the station is at the vertex for B and the ending vertical curve station. So we know it starts out at 87 plus 00, and we know that from the vertex to the center, or actually our new beginning of vertical curve to our vertex at B is 300 feet. So we're going to add 300 to it. So that's going to give us 990 plus 00. Now we have to add another 300 to it to get us to the very end, and that gets us to be 93 plus 00. Okay, so that's how we come up with these stations here. All right. In the book that I'm using, we're using equation 25.4, depending on what version you're looking at it, but I show you the equations as we go along. So that's how we're going to be set up. What we need to figure out is the elevations at each one of these stations. Okay, remember that when we're working with distances, or our lengths, we're going to be dividing by 100. Okay, so we'll go over more in the next slide. So let's take a look at what we have. So in this table here, our information is, we're looking at stations. So we need to know the distance. So the first column is basically what is our distance in feet, and then what is our distance in stations. So the distance from the beginning of vertical curve to the vertex here, from here to here, is the 400 feet. And from the vertex A to the vertex V, from here to here, is 200 feet. The distance between the vertex to station B is going to be here to here, which is going to be 300 feet. Remember, the L1 is 400 feet and L2 is 600 feet. So from the vertex to the end, to the EVC, is your 600 feet. So instead of doing feet, we do stations. So we're just dividing by 100 to get our value. So we have -4, -2, 3, and 6. Now, it doesn't, depending on how you're looking at this, the negatives were just used to do the calculation here. So let's use some common sense. Let me clear that out. The reason I've got negatives here is because I used an Excel spreadsheet in the calculation of this. So let me switch colors. If I know the point right here, if I know this point right here, and its value is 743.24, I want to know grade change up to the vertex A and the vertex B. So what I know is it has to be a greater number than 743.24, right? Because I'm going uphill in this direction. Same with this. Grade at B and the EVC, the end of vertical curve, has to be greater. So I'm going to clear this out. I'm going to take the vertex elevation and I'm going to calculate point A. So I'm going to say elevation at A is equal to 743.24 plus, I'm going to ignore that negative sign, 2% times the distance from here to here, which is 2 stations, or 200 feet, okay? That's this value here. When I take that, it's going to give me 747.24 if you do the math. Now the elevation at the beginning of vertical curve is going to be, again, the vertex, 743.24, plus the 2%, again, ignoring the negative value, times the 4 stations, which is the 400 feet to here, and that's going to give me an elevation of 751.24. All right. Now, to get this point over here, I'm going to take, if I want the elevation at B, I'm going to take the 743, the vertex elevation, 0.24, plus, now I look at that percent, the 1.6%, times the distance from here to here. That's going to be 300 feet, or 3 stations, which gives me 748.04 if I do the math. And the elevation at the EVC, the end of vertical curve, is 743.24 plus 1.6 times 6 stations, which is equal to 752.84. Okay, that's this elevation here. That's what I've done here. Now, again, this positive or negative doesn't really matter, and these negatives and positive don't really matter. If you use common sense, you know that this is the lowest point, and if I need to figure out this point back here, I'm going to have to add values. Okay, so when we're looking at elevations, all we're looking is at slope. the rise over the run. Okay, so that's those stations. That's how we figured out these elevations and stations from previous. Now, the next thing that we do, we're going to use this information to figure out, now, when we're looking at from point A, let me change that color, from point A to point B, I need to figure out what that new slope is. So what that means is I've got a grade. Let me draw this. I'm going to draw it thick. I've got a slope coming down, and now I've got a slope going up. So instead of it going all the way down to the vertex, it's going to stop here and then go up to here. So that's one curve. And then I'm going to have another slope going up or down and then up. So we need to look at these two slopes. So when I'm looking at this, I've got, this is now my G1 and this is G2. Okay? And then this becomes G1 and this is G2 for that curve. So the G1 here, or the G2 here and the G1 here, are the same slope, and that's what we're calling grade at AB. That is this value here. That's that slope value here. So it's actually a positive. So it goes down 2%, up 0.16%, up 0.16%, up 2.6%. All right. So let's take a look at the math of this. So let me clear that up. So the elevation at A and the elevation at B is what we figured up here. So we have elevation at B, let me clear that out. Elevation at B is 784.04 minus the elevation at A is 747.26 divided by the distance. Remember, this is 200 feet to here, and this is 300 feet to here. So 200 plus 300 is 500, but we have to divide all that by 100 because we're talking about stations here. So all that divided by 5. So that's going to give me 0.16%. Now, when we do that, we're looking at the elevations at, now we have to figure out the elevation at where the curves meet. The vertical curves, or compound curves is what it's called. So if we know that from here to here is 200 feet or 2 stations, all I'm going to have to do is say, okay, the beginning, this elevation here, 747.24 plus 0.16% times 2 stations, or 200 feet, is going to give me the elevation of 747.56. That's the elevation at the CVC, the compound vertical curve. All right, so what we have now is we figured out, let me clear all this out, we figured out the beginning of the vertical curve, the PVI of the first vertical curve, and the end of the vertical curve elevation. So this is going to be our curve 1 that we have to do. Now we're going to use the equal tangent curve calculations that we did from the first examples and apply them here. And then we have a second curve. So we're going to have to do basically 2 curves calculation, 2 equal tangent curve calculations. And this is where they'll split. Okay? I'll go into more details in the next slide. Now, here's the same as we did before in the equal tangent vertical curve calculations. The first thing that we had done is calculate our R1, or our rate of change. Now, when we have a compound curve, remember what I said is we have one curve here that stops at the compound where two curves come together, and our second curve is here. So the first curve is going to have this information here. This is where our first curve's information is. We've got a negative 2% going down and a positive 0.1% going up. And its total length from this point here to this point here is 4 stations, or 400 feet. Okay? Now, when we do the math of G2 minus G1, so G2 minus G1 divided by 400 is going to give us the 0.54%. So it's G2, 0.16 minus a minus 2, which is our G1, divided by 4 is equal to 0.54. Now, the second one, our G1, is going to be the 0.16, and our G2 is the 1.6 here. So we'll say 1.6 minus 0.16 all over, and from here to the end is 600 feet, or 6 stations. Divided by 6 is equal to 0.24. So there's actually two R's in here, and I call them R1A and R2B. So 1 goes with the curve of 1, and 2 goes with the curve 2. Okay, so I'm going to clear that out. Now, so we have two start points. So in this curve, in this first curve, let me get that. In this first curve here, our beginning point is the 751. So from here to here, we're going to use the 751 for the elevation at the beginning of curve in the equations. Now, when we do for the second curve from here up, this point right here is going to be now our beginning of vertical curve, and we'll use that elevation for the calculations up. Okay, so remember, like we did before, is we first have to figure out our x distances. So from 83 to 84 is 1 station. 85 to 83, there's 2 stations, or 200 feet. 86 to 83 is 300 feet. 87 to 83 is 400 feet. So that's just the difference between these stations. Now, if I look at the second curve, I'm looking at 87 to 88 is 100 feet, because this is a different curve. This is our second equal tangent curve. 89 to 87 is 200 feet, or 2 stations. 90 to 87 is 300 feet, or 3 stations, all the way up to the end. Now, notice that from the BVC to the CVC, from here to here, is a total of 4 stations. And from the CVC to the EVC, from here up, is 6 stations. So we had a 400-foot curve here, and we had a 600-foot curve here. All right. Now, the next thing that you need to notice in this column is, notice that the G1 from the BVC to the CVC, the G1 here is going to be our negative 2%. And then from the CVC to the EVC, our G1 becomes a positive 1.6%, or positive 0.16%. All right. So these are two equal tangent curves that we're now calculating. So our G1x, so here's G1, here's x. We're just multiplying them across to get this value. G1 times x gives us these values. So negative 2 times positive 2 is negative 4. Negative 2 times positive 3 is negative 6. Negative 2 times positive 4 is 8. 0.16 times 1 is 0.16. 0.16 times 2 is 0.32. 0.16 times 3 is 0.48, and etc. So in the next column, clear this out, the next column from the BVC to the EVC, notice that we're going to be using an R value of 0.514, and from the EVC to the CVC, our R value is going to be 0.24. So in the equation of R over 2x squared, we're going to use these values of R. So we're going to say we'll start down here, 0.54 times divided by 2 times this x value is going to give us our value here. So it's 0.54 divided by 2 times, and we'll do this one here, times 2 squared is going to give us 1.08. The next one would be 0.54 divided by 2 times 3 squared. That's going to give us the 2.43. Okay, sorry about the mess here. Now, so once we have this column and this column calculated, we can figure out our elevations. To do that, all we're going to do is, now remember, the beginning elevation that we're going to use is going to be for here to here. The beginning elevation is going to be 751.24, where from here to here, the beginning elevation is going to be 747.56. All right, so I'll clear that out and I'll do a couple examples. I'll take a look at this row right here. Okay, so since I'm working from the BVC to the CVC, I'm going to use the 751.24. 751.24 plus the G1x minus 2 plus the R over x squared, 0.27, is going to give me 749.51. Okay, let's take a look at the next one. So the next one says 751.24 minus 4 plus 1.08 is going to give me the 748.32. Okay, and you keep going up until you hit here. Okay, now once you get there, you're going to change the value that you use for the calculations. So note it's 751.24, but now from this point on, G1x and R over 2x squared, I'm going to use 747.56 plus 0.16 plus 0.12 is going to give me 747.84. I'm going to skip one and just go to the next, just to show you a little bit different. Okay, so 747.56 plus 0.48 plus 1.08 equals 749.12. So that's how you keep doing it all the way up until the very end, using the G1x and the R over 2x squared. Again, you can do the first and second differences. So in this one, you're subtracting these two to get this value, these two to get this value. When you get up to here, when you're subtracting, you're looking at these two values to get this, and so forth. Each one of these are differenced. And then in this one, you're differencing these two values to get the second value. the second difference. Okay, this just confirms that you're calculating it correctly. This isn't required for figuring out elevations. This is just confirmation. All right, so that's it for figuring out unequal tangent curves or compound vertical curves. Okay.